Leetcode video. Today we're going to be looking at Leetcode 1371, find the longest substring containing vowels in even counts. This is a medium difficulty Leetcode problem, and the problem description tells us that given a string S, we want to return the size of the longest substring containing each vowel an even number of times. And we're given what vowels are, and we're told that these vowels must appear an even number of times. So we want to find the longest substring where each vowel that contains vowels, and each of those vowels appears an even number of times. So in this example, the longest substring that contains 2 of each vowel is this over here, and so we return the output 13, which is its length. And we're told, given some constraints, and we're told that that S only contains lowercase English letters. So when we are defining our vowels, we don't need to define, or we don't need to handle the case. So it's case insensitive. So how are we going to solve this problem? Well, this is basically, it would not work with a sliding window. We need kind of like a monotonic condition, and this problem does not give us that. We wouldn't know when to shift and when to expand. We don't get any feedback like that. So how do we solve this problem? Well, my mind jumps straight to a prefix sum and hash map. That's kind of the problem, or I've seen this kind of problem before, and so I would think, we want to use a prefix sum and hash map, but how do we want to do that? Well, the way we can do this is, instead of thinking of it as a prefix sum and a hash map, let's think of it just as a hash map solution, and assume that we have a state. We have a state where all the numbers are even, and then something happens, and then all those numbers become even again. Well, then we know that in between these two states of numbers being even, that basically this entire chunk, all the numbers between these two, or sorry, not all the numbers being even, but all the numbers being the same. So let's say all the state is exactly equal to another state. We know that all the numbers in between here must appear an even number of times, and that they would all be vowels, of course, because we would only factor in vowels. We wouldn't factor in any other characters. So how would we solve this kind of problem? Well, I'm gonna kind of give a pretty basic problem. These problems are a bit more complex. Let's go with something really simple. Let's say O and U and O and U. So this is our simple problem, and we know that the length of this is going to be equal to 4. All right, this is the longest substring containing each vowel an even number of times. So let's actually look at how we can solve this. And the way we're going to solve this is by flexing some of our knowledge of how binary works and creating a state map, where where the state of all the vowels so far is stored as a 1 or as a 0. So let's say initially we're going to have these all as 0. Actually, let me go back. This should instead be A, E, I, O, U. So let's say A, E, I, O, and U. And initially, all the states are going to be equal to 0. So a -1 here is the index position. So this is the index position -1. So, and actually, I'll come to that later. Just it's a little bit confusing. So we come through A, E, I, O, U. The first time is we don't see A, we don't see E, we don't see I, but we do see O, and then we don't see U. Then we see the same again. This time we've seen O, but we'll also see U. Next time, O, O. What happens here? Well, now we've seen O 2 times. So we would put 2, but in binary, we would get a remainder 1, so we would just put 0 and then 1. And then here, we would do 0, 0, 0, 0, again, 2, but really, though, it's going to be flipped this bit to 0. Okay, so now we've come to the end of our string. Have we found a substring? Well, look at our state. It's all zeros. Have we seen this before? Yes, we have at position index -1, which is why we wanted to wanted to set all our zeros or our state at -1 as 0 so that we can beat this edge case. So we see this state appearing again. This tells us that there is an even number of vowels in between these two states, and the length of that is going to be equal to 4, which is what we're going to return in our result. So I hope this makes sense. Basically, if we have two states and they both equal each other, well, then we know that all the numbers in between those states, all the even numbers, also not the even numbers, the even, all the vowels appear an even number of times. So let's actually get to coding this problem. We want to have count, and this is probably the painstaking part where I need to put A as 0, E, I, O, and U, and then let's just map all of these bad boys to 0, 0, 0, 0, and let's make sure that you are in quotes. Yeah, okay, cool. A, E, I, O, and U. So now we have our count hash map, and this is going to contain the current state. And then a hash map is going to include basically tuples. We want tuples of all the states that we've seen so far. So initially, we're just going to, again, like in our example, we're going to set this equal to, we're going to set them all equal to zeros. And we're going to set the index of this initial state to be -1. And then we want to have a result, which is going to also be equal to 0. And then we want to say for I in range of length of s. Okay, so the character is going to be equal to, what's the character going to be equal to? Si. And if that character is in count, we want to say count of that character, let's increment u by 1. Okay, now state is going to be equal to, well, actually, do we need a state? Yeah, we want a state, so we want to create a state variable, and we're going to set this equal to a tuple. And the reason we want a state, of course, is so that we can, flip. If we get to we want to flip the bits properly, so we want to make sure that that parity, the binary parity, is maintained. So we want to say mod 2, so we get either 0 or 1 for C in count.values. Okay, now if we see the state in the hash map, if the state is in the hash map, well, then we can say result is going to be, and we want to get the maximum substring, so the result of what maximum already is, and then we can set that equal to I minus hash map state. Okay, otherwise, what's it going to be? We're going to set hash map state equal to I. And then we can just simply return our result. And so we're basically, this is basically it. We're saying if the state is in the hash map, then we know that we've found a chunk where all the number of vowels in between all appear an even number of times. Otherwise, we're just going to add our current state to our hash map. Okay, and then we want to return our result. So let's submit our code and check that this passes all test cases. And it does, it passes all 55 test cases. So in terms of time complexity for this kind of problem, classic prefix sum hash map problem, big O of n for both time and space. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.